Welcome to the University of Pittsburgh's Health and Explainable AI podcast. I'm your host, Jordan Gospore, a health and science reporter. Join me as we cover advancements being made in health informatics and explainable AI for students, researchers, and healthcare practitioners interested in applications of artificial intelligence and machine learning. This podcast is produced by the University of Pittsburgh's Health and Explainable AI Research Laboratory at the University of Pittsburgh School of Health and Rehabilitation Sciences Department of Health Information Management. Headed by Ahmad Tafti, Pitt's HexAI Lab cultivates extramural collaborations with academic institutions both nationally and internationally through its research, educational contributions, and this podcast series.
Hello, and welcome back to Pitt HexAI, a podcast series produced by the University of Pittsburgh's Health and Explainable AI Research Laboratory. I'm Brent Phillips. I produce the podcast, and today I'm going to guest host an interview with Ashwin Kumar, who is pursuing a PhD at Washington University in St. Louis. Ashwin is working on improving fairness in multi-agent reinforcement learning. And recently, I asked Ashwin for his thoughts on the subject of AI transparency. And I thought we'd turn our discussion into a podcast interview, in part based on the close relationship between aspects of transparency and aspects of explainability, which is the focus of our podcast at Pitt. So, Ashwin, welcome. To get us started, would you like to introduce yourself and summarize for us what you're working on at Washington University?
Hi, Brent. Thanks for the introduction. So happy to be here. So, as you said, I'm working on my PhD at Washington University in St. Louis. My primary research focus is improving fairness in resource allocation systems, and I'm looking at methods like multi-agent reinforcement learning and constraint optimization to do that. Maybe we can talk about it a little more in detail later on. But I've also worked on explainable planning and designing visualization systems. That's like the three core areas I've researched on.
That's really cool. You mentioned your mentor, Dr. William Yao, I believe that is, at Washington University in St. Louis. Would you like to tell me about your advisor and the focus of his work and your work together?
Yeah, sure. So we are called the Yoda Lab. It's Yo's Optimization and Decision Analytics Lab. And we have like a group of 4 students. We are all working on different things, but it's really fun. William is a great advisor to work with. He's super nice, and he's really supportive if you were a little adventurous in your research, which I find really freeing. And he's supported me throughout this entire journey of researching fairness, even though he had not worked with fairness before. And then I think we're doing some good work here. And the other people in our lab are working on things like information propagation in networks and explainable AI, and more recently, it's like logic-based methods for scheduling and even for fairness. So yeah, do check out their work. Just look up Yoda Lab and you'll find all of us.
Before we dig into your work, we always like to ask our guests about their background and what got you interested in artificial intelligence and fairness. And tell us a little bit about your academic journey.
Oh yeah, sure. So yeah, I started off as a mechanical engineer. My undergraduate degree was in mechanical engineering, but I was focused on the computational aspects of it. And so I applied to a lot of PhD programs in computer science, and I got accepted to work with Washington University in St. Louis, and then I rotated with William, and I was able to join there. So when I started my research, I was very new to research as an idea. I was working with visualizations and looking at user interfaces to see how people interact with systems. I was working with another student on explainability and classical planning. And then I had another project where we were trying to visualize a ride-sharing system. So we were trying to look at a map of Manhattan and see, okay, where are people getting more requests, lesser requests based on some state-of-the-art algorithms? And that brought up the question of fairness. Like, is this possible to route drivers in a way that ensures like people in different areas of the city get a similar service rate? And that's, I guess, where my primary interest for my thesis came out. We modified that algorithm, the state of the art that was being used, and we were able to show a much better fairness with minimal loss in performance. And so that kind of spurred on my entire research. Like, can we generalize to other resource allocation problems where you have a limited set of resources and you have multiple agents who want to take these resources. And how can you add fairness as an optimization objective while also maintaining good utility? So that's kind of overall what I've ended up working on.
So just out of curiosity, I've recently been to New York and I plan to go back at the end of the month, but, pulling up your Uber app, for the average consumer, we're talking about transparency here and fairness, and you're interested in human machine interaction. And we'll talk about this later, but what do you think the app would do for the rider, the Uber rider, to help them kind of visualize how the system is being fair for them? Like, any thoughts on this?
That's a great question. So when we were designing that visualization system, we were looking at it more from like a system administrator perspective. Let's say, the city's government maybe is trying to ensure that any public service or any consumer facing service like Uber, Lyft, they have equal coverage in all areas. And what we found was that the algorithms that we were looking at were better at servicing passengers in busier areas like midtown or downtown. But if you look at North Manhattan, that area was wildly underserved. So maybe an interesting metric there was, depending on your area, how many of the passengers that actually want a cab get one. Or if you want to look at it in a different way, what's the difference in pricing based on different areas of the city? There could be a dashboard for that. And then you could see, okay, maybe if people from a certain area are paying a lot more to get the same kind of rides. And that, I think, would build some trust in the system if you can explain why the pricing is in a certain way. And that could also guide how we make decisions to ensure that there's lesser bias or it's more equitable depending on what the metric is.
Yeah, I was just thinking about that. And I was going to ask you about your work currently, but since we're talking about transparency and kind of the consumer side of transparency, I mentioned when we spoke that I've got to produce a podcast interview for the Humanitarian AI Today podcast, and the episode is being commissioned by the UK Humanitarian Innovation Hub, and they asked us to record an interview on AI transparency. And for the humanitarian community, a lot of humanitarian actors, when they think of transparency, they think of open data sharing with an emphasis on transparency in how aid funding is being spent, where it's going, who's using the funding, what kind of results are the activities generating, things like that. But for an AI expert like yourself, the sort of nuts and bolts behind transparency and explainability is quite technical. And maybe you can just share for us, how do you describe transparency to a layperson, a non-technical person? How do you describe how it's a technical subject from your vantage point?
That's a great question. And I'm not sure there is an easy answer to this. So the first thing that comes up whenever I'm discussing either fairness or explainability or transparency is that you need to define what you mean by that word. Like even fairness, you can have multiple definitions. One way to be fair is that you give everyone equal stuff. If you're allocating resources, everyone gets the same amount. But maybe that's not the best way to think about fairness. Maybe you want, let's say in case of ride sharing, let's say you want drivers who are working for longer hours to get more passengers. It's proportional to how much input they've given to the system. And in that case, having everyone get an equal number of passengers might be unfair. So it depends on your definition. And I think it's the same with transparency, where in AI models, transparency is often thought of as we should know what data went into the system. We should know what algorithms are being used to train the system, and we should know why a certain decision is being made. I guess the why part also touches on explainability. And I think in terms of open data and funding, I think that's a side of transparency that I haven't seen many AI researchers touch on. But of course, open data sharing is a very big issue these days, especially with like the large language models coming up. There's a lot of people are arguing about the distinctions between open weights and open data. So it's like open source has been further divided into what exactly are you doing. I think it's an interesting question, and perhaps it's worth thinking what the definition should be for transparency.
Unfortunately, you mentioned weights, and it's an interesting subject. And just to get ourselves on a tangent, how do you describe weights? to somebody who isn't a technical person? Like, let's say I need to download the weights to a model so I can use the model, but what am I downloading when when referring to the weights? Like what, I need a bucket.
Okay.
Like we tried to download Llama when it
Yeah.
first came out, and I needed like 32 gigabytes, and I didn't quite understand what I was downloading. Do you want to share for me what that is?
Let me try to break it down. I guess what's the best way to do this? So any AI model doesn't need to be machine learning. It can be any kind of AI model. There are some parameters. It's basically you have some set of inputs, then you're doing some mathematical operations on that to get your output. That's the underlying operation behind most AI models. ML uses matrix multiplications. There's a lot of matrix multiplication going on. You have inputs, you multiply with the matrix, you get some intermediate inputs, which you further multiply again and again. That's what deep learning is, how many times you do this. So the weights are basically these matrices that control how your input is converted to the intermediate inputs or the intermediate outputs, and that's essentially what you're downloading. It's a way of encoding how a model transforms what you're giving it into something that it can represent mathematically and then solve your task using that information. I hope that made some sense to you.
Thank you. And actually, this is a great segue into your work, which is quite technical as well. And tell us a little bit about fairness in multi-agent reinforcement learning, and maybe start for the layperson, what's multi-agent reinforcement learning? And where, we can use the example of Uber again. We have these new chatbots and digital assistants and things, and people are building applications with, multi-agent systems. But tell us what's under the hood there.
Okay. So a multi-agent system at its core is just, let's look at a single agent first. In reinforcement learning language, an agent is just a unit which can interact with the world, right? The world has its rules. If you drink water, there's lesser water in your bottle, and then there's more inside you. So there are rules in the world. You take some actions, you get some feedback. An agent is in reinforcement learning. An agent is just something that can interact with an environment, and it learns to maximize some reward. Right? In case of an agent that wants to fill up a water bottle, its reward is how full is the bottle at that point. Something as simple as that. Now, in multi-agent settings, the tricky bit is that you have more than one agent, and each of those agents is trying to optimize for their own personal rewards. And there are very interesting interactions between these agents that that could result in collaborative behavior or competitive behavior. It's a whole field, but I'm trying to summarize it as succinctly as possible. So what I'm working on here is in multi-agent resource allocation. So let's say I'll explain it in terms of Uber again, as we were talking about it, or ride sharing in general. Imagine that instead of each taxi driver independently selecting, okay, I'm going to pick this passenger or not. Imagine if there are autonomous vehicles, and then there's some central decision maker who gets to allocate passengers to taxis, right? Now, each taxi is an agent in the setting, and their goal is to maximize the money that they get from dropping and picking up passengers. So the more people that they serve, the more they earn. And so maybe a taxi would be incentivized to prefer passengers that are going to downtown because there are more passengers available there. So, you can make more money. Or you might not want to go towards the airport at 2 a.m. because you might not get a ride back. So each agent is maximizing their own local decisions. The central agent, at least in my framework, that's what I'm working with. There's a central agent that looks at all these preferences across agents, and it arbitrates based on, okay, there are just 2 passengers, but 5 drivers want the passenger. Who should get this passenger? That's what the central decision maker is doing. And this whole system together is what I call multi-agent resource allocation. And in the context of ride sharing, what we worked on was like a reinforcement learning system, which basically just simulates taxis moving about in Manhattan with real passenger requests, like real data from a period in, I think it's about 10 years ago now. It's just a period in May 2013 that you get actual data from passengers who wanted to go from point A to point B. And you drop a lot of taxis in the city and see how many of those people were actually served. And so the agents learn by interacting with the environment. And if they drop off passengers, they get rewards, and essentially they learn to take passengers, which lead to higher rewards. And so the fairness aspect here, I guess that's where my work comes in, is first you have to describe what fairness means. So in my case, we looked at two things. First was we want to be fair to the passengers, right? Regardless of where you're coming from or where you're going, you should have an equal likelihood of getting a ride. So that was our goal. So in our approach, we designed a method to just change the utilities of the agents, or like how much an agent prefers to pick up a passenger. We slightly tweak that for the central agent so that it also captures the fairness. And basically, the approach is called simple incentives, and the idea is just you incentivize people from areas where the service rate is lower, so you increase their value in the system. This could be done through subsidies or additional monetary compensation to the drivers, um, or this could be like a system level thing that Uber internally does, for example. So that was one kind of fairness, and the other kind of fairness is for drivers, where we want all drivers to essentially earn similar amounts of money. You don't want some drivers to end up in areas of the city where there are very few passengers and they just end up stuck there. So we had a similar incentive-based structure for the central agent, where if if an agent has been seeing fewer passengers in the past time period, they would be routed to areas which have more passengers, and so that ends up solving the fairness problem for the most part. But again, it's a soft solution; it's not like a constraint-based solution, but it works in practice.
With this podcast focusing on health and explainable AI, it's interesting thinking about healthcare, medical care, doctor time, nurse time, access to resources. And, we could easily apply what you're working on to this domain as well. And I'd like to ask you about your workspace and your tech stack and all that.
Yeah.
But before we do that, I'll change subjects again just a little bit. But what kind of lessons learned can you share with researchers looking at allocating resources in a healthcare field based on a multi-agent sort of network and routing and these sort of logic chains? And
My advice here is
like, what have you learned? What have you learned? Give us a good takeaway.
so. I think one of the lessons I learned while I was maybe 1.5 years into this project was that simple solutions are better than complicated ones. It seems obvious to hear it from someone else, but when you learn it for yourself, I guess that makes it hit differently. There are so many modern methods available. Like, you could use ChatGPT for anything. Try to get an LLM to generate your matchings of doctors to patients or whatever in the healthcare setting, right? But in the end, it turns out that human scheduling is actually quite good. We are doing things pretty well, and there is often a reason to things that we can't exactly encode to communicate to the AI. But if you have a very simple solution to any problem that tackles the heart of it, uh, that's better than a very complicated system that would solve a general problem. If you have a specific use case, that's what I've learned, that prefer simpler solutions.
I was just reading about these new code editors, Cursor AI,
Yeah.
and a new one called Zeb that I'd actually heard about. I don't know if you're familiar with Atom, GitHub. They made a code editor called Atom, and they discontinued that. And a lot of the people who worked on it started their own code editor, and now it's sort of a AI powered code editor, code completion tool, and things like that. But like working on these applications and coding them, and it's quite complicated. And do you see yourself using these new tools? Like, how much of that is going to be incorporated into your work in the future? And then back to what you were just saying about often the human solution is better. Like, you're interested in human machine interfaces, and I think Zeb kind of specializes in being able to talk to the editor. Like, I think they see that direction, and to be able to talk to your work and to try to have it sort itself out, but nevertheless stick to kind of a human logic.
Yeah.
But keep the human side in it. How do you see the future looking, and what are your preferences, or what are your thoughts?
Unlock the future of AI at Pitt HexAI. Pitt HexAI is where the brightest minds at the University of Pittsburgh come together to push the boundaries of artificial intelligence. Tune into the Pitt HexAI podcast to hear experts discuss cutting-edge AI research and its real-world impact. Join us at Pitt HexAI and listen to the podcast today.
So I haven't used Zeb, but I've used GitHub Copilot and in-text completion for code, and it even works for text in some ways. I think it's really useful in increasing productivity in the sense that I don't have to type the same code with one word change 3 times. It speeds up things that are very obvious to do, and when it tries to autocomplete code that I'm yet to write, like when I'm yet to formulate stuff, it's often wrong. So I don't rely on it to do my work for me, but it is useful in doing the grunt work, so to speak. And I think that's very important because it lets me be more productive in the same amount of time. And of course, it's good for brainstorming. Like once in a while, it comes up with a solution to I'm trying to rewrite a function, and it'll create a very elegant function or like a shorter version of the same thing, and it makes sense once I read it. So sometimes it has its moments, and I think as we go into the future, we'll have more interactive systems which are more human-like in terms of how we interact with them. Because I think it was ChatGPT 4.0, that's the one with the human-like conversation, right? I think that kind of system would be more and more prevalent. It's just just naturally talking to it, and maybe not even talking, just gestures, interacting with your hands, and physical AI, embodied AI is going to come up soon. And I think that's the next gen of human AI interfaces, and I'm excited to see where that goes.
I'm fascinated. You were talking about explainability and looking at your work. What kind of visual interface do you work with? And like getting back to your workspace and your tech stack and what you do and how you visualize explainability and fairness. Like, what does this look like on your computer screen? Do you see yourself studying explainability and fairness with your voice? And how's that going to look?
I haven't thought about that specifically, but like my tech stack right now is just simply a VS Code window and a Google Chrome tab. That's what I work with. And okay, I might be lying slightly when I say one Google Chrome tab because it's like tens maybe sometimes. It blows out of proportion. But I think the most useful additions to my tech stack have been the quality of life improvements to just using VS Code, where GitHub Copilot was one. Then there's this CSV extension. So a lot of my results, I put it in a CSV, and it automatically colors each column and sorts them. And it's a very small thing, but it helps immediately draw my eyes to the right thing, and it helps me filter through data better. And I've been using TensorBoard a lot. I think that's old, but it works. What else? I think with the modern experiment tracking like weights and biases, those are also catching on. I'm a little slow in picking up those things, but I think over time, I don't see myself talking to my code, not yet. But if that happens, I'd be excited to try it out. I'm not sure how that would look like. Yeah, because coding, it feels like it's a very technical thing right now, even after all these tools to help you do it, linting and autocorrect. It's still a very technical, and it's not a soft field, so to speak. Like a lot can go wrong if your syntax is wrong. You can have errors that you can never catch if the syntax is correct, but it's like a logic error. So yeah, I don't see it being conversational just yet.
I was going to ask you, are you kind of creating like a sandbox for yourself, a little, your own chatbot, your own digital assistant to kind of mess around with?
So I've been trying to do this with smart home lights. That's like a side project of mine. So I wanted to basically create like some sort of interface, maybe voice activated or which is also an app. I could maybe physically connect a knob to it. Just experimenting, because Alexa can or Google Home can do all these things automatically. But if I want to personalize it, if I want to like have a few buttons on my desk, if I press one button, my lights turn red or something. I don't know. Just experimenting with control, and what to do after that comes later. But then I'm a musician part time, like just as a hobby. I play the guitar and piano, and so I'm I'm also interested in seeing if these agents, like language model kind of agents, multimodal AI, can be used to help with musical creativity. Like it's really hard to get thoughts from an instrument onto a digital media, and maybe someone comes up with tools for AI jamming, or just interactive AI for recording your ideas musically. I guess that's something I'm looking forward to. Or if I can build one, I'd be more than happy to do it. But I think I don't have the compute for that yet.
Thinking about laboratory medicine,
Mm.
let's say a lab wants to experiment with these large language models and interfaces where you control the lights in the lab, or the microscope, or warming things up. Hey, you get there in the morning and you want to warm up the lab, and the 100 different things this could entail. It is a learning process to figure out how to do this. We can't all look for a third party to kind of design it for us. And do you advocate for learning? We all need to jump into this, but it is kind of intimidating. We try to speak to students on this podcast series and encourage them not to be intimidated by trying this stuff out. But tell us a little bit about your journey to overcome your own intimidation of tech.
I think you make a really good point that things seem intimidating, and I just like to say that they are intimidating. It's not meant to be, or it's not at the stage yet where you can just look at half a page of information and then do these things. It's not that easy yet. But the fun part of it is that when you get into the weeds, when you actually understand how things work, that's when you have more control over what you're doing. And so what I like to tell people who are asking me like questions like this is that it's worth it to spend the time to put in a little effort. Even if you don't get the perfect product out of it, you'd figure out that towards the end, when you're done, you've learned a lot more than you thought was there to learn. It's just that the amount of information in there it's vast in so many dimensions that you're not going to learn all of them, but you might learn more in a few that might be useful in later whatever projects that you're doing on your own time.
Is there a favorite application or language or something that you see on the horizon that we all should be learning? Like LangChain, like should we all be learning that, or what? If you had to create a list of 5 things for a student, what would be your 5 recommendations for, if they're kind of starting from zero, or if they're, again, like a lot of students associated with Pitt's Health and Explainable AI Research Lab, they're interested in health informatics, so data analysis and healthcare and things like that. But what do you recommend?
So I am a Python person for the most part. I think for data analysis, it's R or Python is the popular choice typically. And if I had to get someone started personally, I would just ask them to learn a little bit of Python scripting and learn how to interact with data, maybe using pandas, and learn at least one library to plot data. It could be Plotly, it could be Seaborn, it could be just Matplotlib. Um, Seeing what you're doing as a figure really helps. So that's, I think, one skill that it's kind of necessary to do any kind of meaningful exploration with data. And then I think LangChain is probably a really good tool to learn if you're trying to interface with LLMs. I haven't played around with it too much, but yeah, it was easy enough for me to get up and running with like half an hour of work. So I think that's easy to pick up, and then the possibilities are endless from there on.
You mentioned your Google tabs. Do you experiment with Google Colab notebooks? Thinking about our lab and other labs that want to kind of experiment with this stuff, a Colab notebook is actually kind of useful for kind of mapping things out and then engaging, a room full of people around a project, and you could, articulate what you're trying to do and have people ask questions and then kind of write bits of code and have it in there and to try to help out. But what's your view on these notebooks?
So I haven't used Colab that much, but I've used Jupyter Notebooks a lot. I think the idea is similar. I think it's great for prototyping. Like, it's great for understanding how a system works. I used to write full-on scripts and then test them, but then over the years I've learned to not do that and just open up a Jupyter Notebook and build up whatever script I'm working on part by part. So instead of building a whole monolithic structure, you want to test out small things. You want to maybe swap out what chat model you're using, or what's your evaluation string looking like. You could swap that out within a single block and have the rest of the code still there. So I think it's really useful for rapid development. Like, it's helpful in getting a sense of what different parts of your code are doing, and then later on when you're deploying your code, of course, you condense that into a script and you let that run offline or online. But yeah, in the development stage, I think a Colab notebook or a Jupyter notebook is great.
Thinking about working in notebooks and things, obviously we're interviewing you today and we're taking you away from your work. But would you like to share for us what you're working on at this moment and what you plan to work on imminently? Like, what are you excited about and what's on your agenda right now?
So personally, for my projects, I'm working on trying to learn fairness. So you remember the first project I told you about with ride sharing, where we were doing simple incentives for fairness. Now, the natural extension to that question was, is it possible to learn like a function that automatically gives you, given an agent's decisions, what's the best fair decision, so to speak? Um, and then we're trying to do this in small toy environments. It's kind of theoretical, but we're trying to see if, given different fairness metrics, it's possible to learn a long-term estimator for fairness given certain actions. And we're trying to see if you can learn this in the constraint setting, like with a central decision maker. So because there have been some papers which study this, where each agent is acting independently in multi-agent error, but there's not been much research in what if there is a central decision maker who's arbitrating across agents. So we're trying to see if it's even possible. If we found that existing methods don't really work well in the setting, and just trying to make sure that what we're doing is bulletproof, trying to aim for a conference submission soon.
Do you want to talk a little bit about the central decision maker? Like, what's complicated about it? I was just thinking about sort of a health regulatory environment, and it's easy to say we need to have fairness and X, Y, and Z, but to actually code it and to test it and evaluate it.
So typically in multi-agent RL, how the problems are set up is that you learn through experiences. So each agent is doing some actions, they get a feedback on that action, and it could be a bad feedback or a good feedback, and they learn from that experience. What happens with a central decision maker in this case is that you take an action, but you might not exactly be able to do that action. Like, you want to take patient A, but you might not be assigned patient A. So then the feedback that you get is dependent on what everyone else is doing and what the central decision maker thinks that you're doing. And that kind of complicates the learning process a little. And so some of the better algorithms for single agent reinforcement learning don't really scale to this setting. And I'm trying to see if we can still learn from this experience. You're doing something you don't want to do, but that's still useful information. So how do you capture that, and how do you use that to inform your later decisions? Did that answer your question?
Yeah, it did. And it almost seems like you have so much going on just by virtue of asking the agent a question. It almost sounds like you have to dedicate half of the compute to checking itself and verifying all these sort of things that you want to verify to make sure you have the right answer. Like, it's sort of compute intensive to do fairness, probably. I don't know how to ask that question, but I'll let you tell me your thoughts real quick about it.
It's kind of intensive on the central decision maker, but then that's all the central decision maker is doing. So you can think of it as a two-stage process, and that's kind of the method I'm proposing. It's called DCAF. It's a cute little acronym we came up with, where it's decentralized evaluation, centralized allocation, and fairness. So the decentralized evaluation is where each agent is, let's say agents are doctors in this case. Each doctor is independently evaluating which is the best patient for me to be assigned to, right? And the central decision maker is looking at all these preferences, and all they have to do is they don't have to go through the process of, okay, which one is better for this doctor or not, because the doctors have self-reported that. All the central agent has to do is look at these preferences and try to see, okay, given that this is what the doctors preferred and this is my fairness objective, maybe I should move these around a little bit. So it's kind of split up the work between the central and the agents, and that I think helps with the compute.
Speaking about your work and sort of the landscape around us today, it's just getting more complicated and more technical every minute. And I think it's probably easy to be, again, sort of overwhelmed by it. I mean, just thinking about the complexity of these new multi-agent systems and applications for healthcare, and in a highly regulated environment. And there's a lot going on behind the scenes to build this stuff and test this stuff. And should we embrace that complexity?
I'd speak from an angle of transparency, because I guess that's one of the themes for today. I think complex systems are useful in that as long as they can be modular, as long as they can be confined to a specific area, and then just assume that, okay, they have some input and output, that works in isolation. But then your system as a whole should not look complex. It should be like, okay, there's a decision-making unit that does one thing for us, assuming it does that correctly. How does everything else knit together? How do we get a meaningful decision out of whatever constraints we have? I think complexity is useful if used in a clever way, but having complex systems just for the sake of being up to date is not a good idea. And that's all my opinion.
No, that's good. And as you mentioned before, we need to keep it simple and keep it human. And I think maybe these are good takeaways for the podcast interview.
Yeah.
One question that we like to close the interview on is we ask our guests to think of a project that you would love to see a student work on. But what's a secret project that you would maybe like to work on yourself, but you'd like to outsource it to some students, something cool and something difficult? Give us an idea.
So I don't know how fleshed out this is, but I've been thinking about AI composability. And the goal here is, you have language models, and then you have video models, you have image models, and you might have reinforcement learning systems that make decisions. Now, it would be interesting to see if we can use these as modules in a much bigger system. Like you build your own PC. You can change what RAM you're using, you change what motherboard you're using. And can you compose these AI systems in a certain way to achieve a system, which is, it's end to end, but it has modular parts that you can plug in and plug out, and that lets you interact with a much richer input and output field than you would get with a single model. I think that's really exciting if it's possible to do. And I think what people are trying to do right now is just have a single model that does everything. You feed it multimodal input, it gives you multimodal output. But maybe it might be useful to see if you have a lot of small models that can do different things, and you have an interface that can plug those models in and then interpret, okay, I've upgraded my vision model, I can now make better visual decisions. How does that work? Is it possible to do that? And if so, what are the limitations? What are the benefits? That's something I'd like to see done.
I was just thinking about humanitarian organizations, and there's one called Signpost, which is a part of the International Rescue Committee, and they've launched Signpost AI Lab, and they're building some multi-agent assistance, so a multi-agent system, and they're ramping up their staff really fast. There's some amazing people, but if you were in charge of one of these initiatives and you had to think about what kind of people do I need, what kind of resources, like, again, this is a lot of work just to do some basic research around this stuff, but who would you hire? What kind of skills would you be shopping for? And what sort of basic research would you do to think about, again, back to the healthcare field, like a health application, whether a diagnostic test works or not, and you have, consumers interfacing with the company to find out their test results or something. What kind of work are we looking at?
That's a very broad question. I'd say it's not one kind of person you're looking for, right? In the end, you want a team, and you want people who are good technically, but then they might not be the best to communicate. So you need some people to bridge that gap. You need people who deal with people well. It's a whole task where, as a computer scientist, I know what my algorithm is doing, but I might not be the best at explaining it to someone who does not know computer science. So there are people maybe from other fields, like from ethics or social backgrounds, who are more adept at interpreting what we're doing and explaining it in a more human-like format instead of an algorithm. So we definitely need people who bridge gaps across different fields. And of course, we need people across both ends of that bridge. We need people with people skills and with technical skills. But yeah, that's just a very high level idea. I don't exactly know who I'm looking for.
This is a good answer, and because we've been thinking a lot about the work of the future and education of the future and career paths of the future, and a lot of students are kind of creating their own programs and their own professional fields. And I appreciate that you've inspired so many of them to be a communicator or a researcher or an interface or a Scrum Master, or it's one thing to start with in the medical field or health informatics, and then just sort of find your own way, based on the pace of technology and all that. So thank you for sharing that. We'd like to close the interview by giving you a chance to pitch your own school and your own colleagues. Tell us a little bit about Washington University, right? And do you have a pitch for others to check it out?
Yeah, sure. I think it's a great school. I joined in 2019, and I had like 7 months pre-pandemic, which was a great time to be a fresh student. But after that, of course, the next 2 years were a blur at my home. But I think the university supported us tremendously through all that. And the fact that we have a smaller cohort, so that's, I think, one of the better things about WashU is that, at least the CS program, the students, it's a small batch. So all in all, I think my batch has about 20 students, PhD, across all subfields in CS. And then that lets you work with people across disciplines a lot more than you would if you had like huge labs. I know some places where single labs are maybe 10, 15 people, and most labs at WashU are, I think, much smaller. So that's one thing I really love about it. And then St. Louis is it's an interesting place to be as a student, because it's the cost of living isn't too high. The stipend is more than enough to live a great life, and it's not a college town, so there are things to do other than just going to the school. So I think it's been a fun few years, as like from a work-life balance perspective as well. And of course, you get all the smartest colleagues, and the professors there are great. They're always willing to talk to you. So I don't know. I think I've oversold the school, but I really love being there.
No, I've already planned to close the interview by saying, if you'd like to do another PhD, you can consider our Health and Explainable AI lab. Anyway, Ashwin, thank you so much for joining us today. I've really enjoyed our conversation. And, we do focus on explainability and the idea of transparency and fairness. Like, you've really kind of demystified a lot of this for listeners, I'm sure. So thank you so much for joining us today.
Thank you for having me. It was great talking to you.
Thanks everyone for tuning in and for following the show. The Health and Explainable AI podcast is produced by the University of Pittsburgh's Health and Explainable AI Research Laboratory at University of Pittsburgh School of Health and Rehabilitation Sciences Department of Health Information Management. I'm Jordan Gospore. Thanks for listening.